Today I would like to explain about concurrent force system. In previous class I have explained what is system. System is, it is the place where some process is taking place, or it is the space where some process is taking place. Here which process we are taking? Concurrent forces. Okay. So concurrent forces means all forces are acting at a single point. It may be A point, B point, C point, like that. It is one of the object, given object. So all forces are acting at this point. Okay. For example, I am taking all these forces at this A point. Okay. A is called concurrent point. At this point all forces are acting. Now here I am taking another example for concurrent forces. We can define concurrent forces like this also. The line of action of all forces meeting at one point. Now I am taking one force here, 10 Newton force, and another force is here, it is some 5 Newton force. I am taking one more force here, some 12 Newton force. Okay, and another force I am taking here, it is some 30 Newton. Okay, according to this definition, the line of action, if you extend this line, all these lines, line of action, if you extend all this, all are meeting at a same point. Okay, it is called concurrent forces. Okay, all forces are acting at same point, or line of action of all forces meeting at a common point or one single point. It is called concurrent force system. Okay, now in this concurrent force system, how to find the resultant force? I am taking this example at some C point. So F1 force, F2, F3, F4 forces are acting. So all these forces are concurrent forces because these are acting at C point. Now I am taking these forces as system forces. Four parts. Now initially I will take the first coordinate diagram only. Okay, I am not considering all this. So first one I am taking. So how is the diagram for the first one? F1 is acting in this direction. At what angle it is acting? It is acting 30 degrees. Okay. In the first coordinate, this axis indicates the right side direction. This axis indicates in the upward direction. Now what are the horizontal components and vertical components? As I mentioned in the previous class, if the force is inclined to some angle, it has two components. One is horizontal component, it is acting along this line, and one vertical component, it is acting along this line. Both x and y values are positive. Now here how to find the cos value and how to find the sin vertical value. Now here yesterday I have explained, make the triangle. Okay, you just make the triangle here. Now this is the horizontal component, vertical whatever it is coming we have to mark here. Okay, FV value, FH value. Okay, this is the first force, that's why FH1, FV1. Now by using this triangle, okay, so this is F1 value, magnitude F1, and we need to find this horizontal values, so we can apply cos 30 in this triangle. Cos 30 is equal to FH1 by F1, FH1 by F1. F1 quantity will be given, so we need to find FH1. FH1 is equal to F1 cos 30. Okay, we can find this value by using the given values. Now next we need to find the vertical component. How to find vertical component? Fy1. Okay, V1. So Fv1 we have to take here in this triangle. How to find the value? Vertical component sin 30 is equal to Fv1 by F1. Fv1 by F1. Now here we need to take Fv1 value is equal to F1 into sin 30. Sin 30. Okay. Now here there are two components for this force. Okay, horizontal, vertical. Now how to do this diagram? By taking these two components. Horizontal component. This is the horizontal component. It is acting in this direction. F1 cos 30. And vertical component is F1 sin 30. Now instead of this diagram we can take these two components. Okay, instead of this inclined force we can take two components. So similarly we have to change this inclined component also into one vertical and one horizontal. Here also one horizontal and one vertical. Like that we have to divide entire diagram in terms of all horizontal components and all vertical components. Okay, this process is called resolution of forces, means dividing this force, inclined force, into vertical component and horizontal component. So similarly, I will take the second coordinate. Second is this one. Which force is acting here? F2 force. It is acting at 45 degrees. Now I am taking F2 force. How much angle it is acting? 45 degrees. Okay. Now here for inclined component, how many inclined force, how many components are there? There are two components. One is horizontal and one is vertical. Now here I am taking, so vertical component is acting in this direction. In the second coordinate, x value is negative, so that's why it is in the downward direction, left side direction. Okay, so here how to find vertical component and horizontal component? Here also make this is into triangle. Okay, triangle. Now this is F2 magnitude. Okay, and this is horizontal component FH2, and vertical component same value we can take here. This is FV2. Okay, we need to find FH2 and FV2. So in this right angle triangle, for finding horizontal component, we can consider cos of angle. Given angle is 45. Cos 45 is equal to FH2 by F2. Now we need to find FH2. Okay, so it is F2 cos 45. Okay, similarly find vertical component. So for finding this vertical component in this right angle triangle, we need to apply sine. Sine 45 is equal to FV2 by F2. Now FV2 is equal to F2 sine 45. Okay, so this is the horizontal component, this is the vertical component. Now how to do the resolution force? Resolution force means instead of inclined force, we are taking horizontal component and vertical component. Now horizontal component is in this direction, that is F2 cos 45, and the vertical component is acting upward direction, so it is F2 sine 45. This is the second coordinate. Okay, now we resolve the forces in first one and second one. Now take the third one. So in third one, x values are negative in this direction, y value is also negative in the downward direction. So here I will take the third one. So third coordinate, the diagram is like this. It is acting in downward direction F3. At what angle it is acting? 60 degrees. Now here also we need to find horizontal component, vertical component. Okay, for horizontal component and vertical component, just I am taking one line. So I am making into right angle triangle so that we can easily find these components. This is F3 given. Okay, and now this is vertical FV3. This is FH3. Okay, now here for finding cos value, sorry, for finding horizontal value, we are taking the cos. Now I am taking cos 60 from the above triangle, FH3 by F3. FH3 by F3. Now our main aim is we need to find FH3. FH3 is equal to F3 cos 60. This is the horizontal component, and then vertical component sin 60 is equal to, from the right angle triangle, FV3 by F3. FV3 by F3. Okay, now here our main aim is we need to find FV3. FV3 is equal to F3 sin 60. We got two components, so we have to take resolution of forces diagram. So this diagram is like this. Now horizontal component in this direction, vertical component it is downward. I am taking here this component. Now FH3 means F3 cos 60, and downward vertical component is F3 sin 60. Okay, so this is the third coordinate, and I am taking the fourth one. In fourth coordinate, if you are taking here in the fourth one, horizontal component is in the positive direction and the vertical component is in the downward direction. Now first I am taking the main diagram in the fourth coordinate, fourth one. Now the diagram is, given diagram is like this. F4 force is given. How much it is making? Given angle is 25. Now again for finding the components, I am taking into right angle triangle. This is the vertical component FV4. This is the horizontal component FH4. Okay, for finding the horizontal component value, we need to consider cos 25 is equal to This is the magnitude F4, it is given. FH4 by F4. Okay, so FH4 is equal to F4 cos 25. Now similarly, this is the horizontal component. Similarly, for vertical component, I am applying sin 25. Sin 25 means it is the opposite vertical component by F4. FV4 by F4. Now here I am taking FV4. It is the required value. F4 into sin 25. Okay, this is the vertical component. Now I am taking the resultant resolution forces. Instead of this force, we did horizontal, vertical. Horizontal is F4 cos 25. Vertical is F4 sin 25. Okay, so in all these cases, instead of inclined diagrams, I am taking into two components for each inclined force. Okay, so like this. Now here, how to draw the entire combined diagram, this diagram, this diagram, this diagram and this diagram. Now I will show you how to do it. Here I took the given diagram like this. Now I am doing here resolution of forces diagram. Resolution of forces means I am dividing all the inclined forces into two components. One is horizontal, one is vertical. So here this is the x-axis, this is the y-axis. Because of this F1, it has two components, that is FH1. FH1 means we did F1 cos 30 and the vertical component is F1 sin 30 from this diagram. FH1 means F1 cos 30, FV1 means F1 sin 30. For the second force, for this force, I am taking the two components. Those are here FH2, FV2, like this. Two components. So these two components I will mark here. So FH2 means it is the value F2 cos 45 and vertical component is F2 sin 45. And then from the third coordinate like this. Now I took these values. Horizontal is F1 cos 60, vertical is F3 sin 60. This is left side direction, downward direction. Now left side direction F3 cos 60, downward direction F3 sin 60. Now for this fourth one is horizontal component, one is vertical component. Those components we did here in this diagram. F4 cos 45, F4 sin 25, F4 cos 25. So it is in this direction F4 cos 25 and then here F4 sin 25. So, okay, this forces are called resolution of forces. This dividing this into two components. One is horizontal and one is vertical. Okay. Now here we can apply the same rules for finding the resultant force. How to find the resultant force? What are the conditions for finding the resultant force? Now here, as we know, sigma Fh, for getting the equilibrium condition, all unbalanced horizontal forces should be 0 and all unbalanced vertical forces should be 0 for taking the system into equilibrium. At that time only the given point or taken object is in constant position or equilibrium. Okay, if some value will be there, it has no balance, it has some resultant force. Okay, apply these two conditions. Sigma Fh means sum of all horizontal forces. Sigma Fe means sum of all vertical forces. Now what is the resultant here? So resultant means it is not the balanced one. Okay, we have to take this value, we have to balance that system by using the Newton's third law. We have to apply the same amount for this system. At that time only all sigma horizontal forces should be 0 and all vertical forces should be 0. Now what is the equation? Sigma Fh whole square plus sigma Fv whole square. Why we are taking this equation? In right angle triangle, resultant side of the this diagonal length, it is a diagonal length. So we are taking, this is the horizontal forces, sum of all horizontal forces, sum of all vertical forces. So this is the formula. Now here we need to find what is sigma Fh and what is sigma Fv. Okay, and how much angle it is acting, phi. If you are taking phi, now the for finding this phi, tan phi I am applying, because we know this value, by using these given values. Sigma Fv by sigma Fh. Now from this, phi is equal to tan inverse of sigma Fv by sigma Fh. Okay. Now we can find how much resultant, how much angle it is making with the horizontal. Okay. Now here we have to take first condition of this sigma Fh. Sigma Fh of this system is sigma Fh is equal to, I am taking in the box, all sum of all horizontal forces. What are the horizontal forces? 1, 2, 3, 4, because those are acting on the horizontal line. This side direction I am taking positive, and this side, left side, is negative. I am considering negative. Now first write down the positive values. F1 cos 30, and then plus F4 cos 25, and this side negative, minus F2 cos 45, minus F3 cos 60. Okay. Now here, now take down sigma Fv. In sigma Fv, what are the vertical forces for this? So vertical forces are F1 sin 30, F2 sin 45, and F3 sin 60, F4 sin 25. 2 are upward direction, I am taking positive in this direction. 2 are negative, downward, I am taking negative value. Okay. Now sigma Fv, if we write sigma Fv, what is the first force? F1 sin 30 plus F2 sin 45. F1 sin 30 plus F2 sin 45. So downward forces minus, okay, minus F3 sin 60 minus F4 sin 25. This is the vertical component. Okay, by using the given values, all values will be given, F2, F3, F4. If you are substituting all these values by using calcium, you will get some value here, and sigma Fh has some value. Now if you are applying these two values in R, we will get the resultant force, and we can get the angle also, phi value. Okay, by using these two values, we can keep the equilibrium position by applying the same R value in the opposite direction. This is a procedure of solving the resolution of forces in concurrent force system.